Okay, today we're going to do 4.5 linear and exponential functions for SAT Math Level 1 preparation. Linear and exponential functions, you got 46 points here of notes to take. Hopefully you got a note-taking guide. And then 64 points in the skill sheet, which is after this PowerPoint video, but not included. If you want the skill sheet, email me. Overview. SAT assumes you are familiar with the characteristics of two important classes of functions, the linear function and the exponential function. The greatest power of the variable is 1 in a linear. The key distinguishing feature of linear is the rate of change between the variables will be a constant. So in an exponential function, the variable is an exponent, as in y equals 2 to the x. The rate of change between the variables is not constant, but changes by a fixed percent of its previous value, as when interest on a savings account is constant. And in a linear function, the graph of a linear function is a straight line. When it's written in the form f of x equals mx plus b, m is the slope of the line AB, its y-intercept would be here, would be b. And it has a function of 3 here, so as x increases by 1 unit, y increases by 3 units. Rate of change is 3 over 1. The slope of a line represents the rate at which the linear function changes in value with respect to x. Linear functions can be used to represent situations with constant rates of change. So this example here, a certain 4-inch spring stretches 1.5 inches for each ounce of weight attached to it. So the length of spring L when an x ounce weight is attached to it can be represented by this function here. The car starts a trip with 20 gallons of gasoline in its tank and consumes gas at a rate of 1 gallon for each 25 miles traveled. After traveling X miles, the amount of gas remaining in the tank would be this amount right here. Interpreting the parts of a linear model. So it represents a model real-world situation. The values of constants A and B have specific meanings within the setting described. So typically, constant A represents some starting value for y or some initial condition. B tells for each unit change in x how much y increases or decreases. If the dollar value L of a certain laptop computer decreases m months after its purchase, according to this equation here, then negative 28 represents the number of dollars of value a laptop decreases each month after its purchase. When there are X milligrams of certain drug in a patient's bloodstream, a patient's heart rate in beats per minute can be modeled by this function here. Which statements are true? So 10 minutes after taking the drug, the patient's heart rate increases to 75 beats per minute. 2, when the drug is not in the bloodstream, the patient's heart rate is 70 beats per minute. 3, for each milligram increase in the drugs in the patient's bloodstream, the patient's heartbeat increases 5 beats. The model does not explicitly consider time, so statement 1 is not correct. When x equals 0, statement 2 would be true in that case. And statement 3 is true, since each time x increases by 10, h increases by 5 beats per minute. The correct choice here would be C. So graphs as models. A graph of a function can model a situation by giving a visual picture of how one real-world quantity measured along the vertical y-axis depends on another quantity measured along the horizontal axis. So here is our domain here. This would be our range here. Shows how the cost in C of dollars of manufacturing a certain product depends on the number of units manufactured. So your domain would be here, your units manufactured, this would be your dollar amount. And then to find an equation of a line, write the general form of the equation, c equals ax plus b, where a is the slope and b is the y-intercept. Because a equals 45, b equals 120, here's 120. The equation of the line would be 45x plus 120. So the graph represents the yearly cost of playing 0 to 5 games of golf at the Sunnybrook Golf Course. Here's a graph here, which includes the yearly membership fee, which would be right here. What is the cost of playing one game of golf? Write a linear function that expresses the total cost in dollars, C of joining a club and playing N games during the year. What is the cost of playing 10 games of golf? Here's the graph again. So for one game, this would be your amount. And then for, I can't remember the other question. The slope of the line represents the cost per game of golf. This is cost per game. Pick any 2 points in line with an integer coordinates such as 1, 120 and 2, 150. The slope of the line. So we plug that into our slope formula here and we get $30 per game. Cost of one game of golf is $30. When the number of games is 0, which will be right here, the cost is $90. The y-intercept represents the yearly cost of membership. Because slope of the line is 30 and its y-intercept is 90. This will be the equation of the line right there. Substitute 10 for n to find out how much it costs for 10 games, and you have $390 here. And its total cost joining club playing games is $390. So the exponential function is the equation in the form y equals ab to the x, where a cannot equal 0 and b is a positive constant other than 1. Constant a represents the initial amount of y for which successive integer values is repeatedly multiplied by the base b up here. So here is an example here of exponentials. Y equals b to the x. If b is greater than 1, then x increases. As x increases, y increases, and the graph rises increasingly faster here. If 0 is less than b and b is less than 1, and as x increases, the line y decreases. Illustrating exponential change graphically, the slope of the line is constant across the line. The slope or rate at which y changes along an exponential curve. The accompanying table of value represents points from the graph of y equals 5 times 2 to the x. This would be the graph here, y equals 2 to the x. Y equals 5 times 2 to the x. This would be the graph here for that. And then this would be the table here where this graph represents this. General formulas for exponential growth and decay. Initial quantity A changes exponentially at r% per time period. Then after x successive time periods, the amount present, y is given by the formulas in the accompanying table here. So this would be a decay or growth. An exponential function in the form y equals ab to x, where b equals 1 plus or minus r. The initial amount A is increasing exponentially of r% of quantity of insects beginning 20 and increases exponentially at a rate of 35% every 5 days. And after 30 days, the number of insects y will be represented by this formula here. So when b is less than 0 is less than b and b is less than 1, the initial amount A is decreasing exponentially at r%. So when you have a situation here, this will be an exponential decay right here formula. The quantity beta is being raised to a power sometimes referred to as the growth factor. So this will be an example here of a town that increases by 3.5% every 6 months. Which one of these would be the formula that would represent that? Growth factors are 1 plus. Eliminate choices B and D. So B and D, because they're less than 1. And then the growth cycles every 6 months. There are 2 growth cycles or compounding periods each year. So this is a dead giveaway right there. Car loses value at a rate of 4.5% annually. After 5 years, what will be the amount? So it's a decay function, we know that. So it'll be 0.955. So V would equal 24,500 times this decay factor here. Correct choice would be D right there. Thank you very much.